Hey guys, you've seen a lot of my face on the videos, but I wanted to introduce my brother. He's really the brains behind this operation. He's my younger brother and business partner, but anyways, this is Tim, and I'll let him introduce himself.
Hey guys, my name is Tim Merritt. So I have a background in electrical and mechanical engineering, and I'm in charge of the engineering department here at L Aline. We also have a very talented software and mechanical engineer working for us as well. And we just want to make a quick video that goes over the design and manufacture of our machines. This is where the design starts for all of our freeze dryers, is here on the computer on CAD software. This is our medium design here, and we are constantly trying to find ways to improve the design, such as moving the electronics up top here. You can see these are some new designs that we're coming out with soon. And so this is really where the design process starts.
So currently some of our electronics are still assembled here. There's people much smarter than myself that are able to do that. But anyways, yeah, this is Chandler. He's one of our more brilliant minds, and he does a lot of our electronics and coding and things like that. But anyways, that's what he's doing here is he's actually soldering down some of these electronics for the boards. So this is our 3D printer. We use it partially for production, partially for just prototyping things. It's actually super nice to have this 3D printer because we can go and test things before we really put it into production. It gives us the ability to just rapidly produce whatever component we're trying to test, and then we can throw it into the machine, see if it works. And anyways, it's been great. These are our bezels that we use for our screens, and anyways, it's actually currently working on a batch of them. But yeah, super nice to have this 3D printer. So this is the point after welding that we go ahead and we wrap the refrigeration coils around the pot. We also install the sensors that are going to go on the outside, and we do the wiring and the vacuum tests. But anyways, so the foam is actually really important for the refrigeration in order to make the refrigeration work. Without the foam, the refrigeration just simply wouldn't work. And it's actually really important that the foam is cast onto the pot, so that way you don't create any kind of like a leak path where water can condense onto the coils. If it were like a sleeve or something like that, water would condense onto the coils, and then you get a bunch of condensation built up inside the foam. But we use a casting process for our foam, so anyways, there's no chance of water leaking or like condensating inside the foam. So this is the foaming process, and one of the things that we do with foam is, it's a two-part mix. So anyways, we got to mix it up. It's kind of a time-sensitive process, and anyways, we just fill it up until it fills up this jig. It's kind of a messy process. That's why we got the apron on, but yeah, this is what we do. So this is what the frame looks like before the pot gets installed. What we did is we made all the frames out of extruded aluminum. Here's a cross section of what that extruded aluminum looks like. It's super strong, very robust. Anyways, these frames are just very strong. So after the frame gets assembled, the pot gets installed. It's a pretty simple process. Just put it in and just bolt it together, and then from here it'll get the refrigeration put into it. So this is the point where we charge the refrigeration systems. We've done a lot of research in how to future-proof our refrigeration systems. There's a lot of things that aren't allowed in Europe, and there's a lot of things that are going by the wayside, even here in the United States. A lot of things that the EPA is phasing out. So the gas that we use for our refrigerant is actually very similar to propane. It's called an isomer of propane, where it's the same molecule, but it's just flipped a little bit. So anyways, this is our charging station. We get everything charged up, soldered up, ready to go, and then we make sure to test the refrigeration system here, and then we'll go through several more tests in the next step. So this is the quality control station. So we line them all up and we send them through their paces. A few things that we're looking for here in the quality control section is we want to make sure, one, that that it's going to function properly, and then two, we're actually looking to degas some of the components like inside the vacuum chamber. So one thing that we notice is that when you have plastics of any kind, whether it's silicone or plastics or heat shrink, all of those compounds will off gas, and it's called what we call in the industry is called a virtual leak. Anyways, so get higher numbers, but then as soon as you start kind of like doing a dry run on the unit, you'll notice that all those vacuum pressures and everything just kind of start to fall. And that's what we're looking for here. We're kind of looking to off gas some of the plastics and some of the components that are inside the vacuum chamber. But anyways, so that's one thing that we do here during the testing cycle. We also go through about it's over 2 hours of just like, testing components and like making sure sensors are working and that they're calibrated correctly. So anyways, we go through like 2 hours of just testing, just like running the systems through their paces. We also look for, any like, quality control issues with like, scratches or dents or, anything like that, anything that we can fix before it goes out the door. But yeah, this is what we do, for this section. And anyways, we just don't send out bad units. And if we do, we take ownership of it. So this is obviously one of the most important tests on our quality control section is the vacuum test. And this is actually the third of the vacuum. So we do 3 different vacuum tests. We do 2 hot tests and then we do a cold test. The 2 hot tests, they can be a little bit higher. They're about, I think 1100 millitorr that we tested at, just because it's a lot harder to achieve 500 millitorr when it's not under under refrigeration. But this test we're looking for, it just started, but we're looking for 500 millitorr when it's completely refrigerated, and we've already gone through the degassing, the degassing tests. But anyways, again, this is one of the most important tests before it gets shipped out, because we want to make sure that you're not going to leak and it's just going to function properly. So after this test completes, there's actually a very crucial portion called the leak rate test. So even if we were able to achieve 500 millitorr at this point, it still could be kind of like, it still could be not accurate if the leak rate is too high. So after this test completes, we'll actually be looking for the leak rate to be under 8 millitorrs per second. If it doesn't pass that, then it's like, hey, we've got to, go and rework the vacuum system, make sure that everything's not leaking. But anyways, even more crucial than this test is that leak rate test. So I feel like every portion of this process is super important, because without one portion of the process being, absolutely dialed in, the machine is not going to function, or in this case, it's going to get to you damaged. So anyways, packaging is super important to us. So we use double-walled cardboard, and then we also wrap it in like foam in order to make sure that it gets to you undamaged. We've had actually really good luck with our shipper. We've only had one get damaged so far, which is, I think it's great odds as far as getting to our customers in perfect condition. But anyway, so we make up our boxes, and then we go and screw them down to a pallet, and then put a unit in it, and we ship it out to you guys.